Number 3 say?
Suppose you have $13,000 to invest. Which of these two rates would you yield the larger amount in 2 years? 9% compounded monthly or 8.89% compounded continuously? 3.
So n equals 12, and this is continuous. Okay, so all you have to do is just apply the same two formulas and just calculate. So for the first one, we have A equals 13,000, 1 plus 0.09 divided by 12, everything raised to 24, 2 times n. And the other one will be 13,000 E raised to 0.0889 multiplied by 2.
I'm sorry, where did you get 24? 2 years.
2 times, it's NT. NT.
Oh, so it's 2 times.
N is 12, T is 2. So you don't have to memorize, as I mentioned, these two formulas. They will be in, if not in this problem, they will be in another problem. Ready to punch it in?
No.
We can do this by hand, so. Oh, I killed my program here. You don't have to wait for me, whatever you have, I'll trust you. Ah, look at that. Yeah, I knew this. I don't know. You don't even know how many times I deleted this video. Number 4 from yesterday. Yeah, this is it. Okay, what do we have?
I got
Yes?
I got 1,555.
But is it possible if we start with 13,000? We start with 13,000, right?
Yeah. Should we be suppose you have $13,000 to invest?
So you have to have more after 2 years, not less. Right? That's okay. Let's try it. So 1 plus 0.09 divided by 2.
2 zeros instead of 3.
That's okay. So that's what I said. Always keep in mind, we should always say, wait a minute. I deposit 13,000 in 2 years, I have 1,500. Right? Always think in those terms. Wait a minute. Okay, 1553.38. 1553.38. And now the other one for continuous. 13,000 times E, parentheses, 0.0889 times 2, close the parenthesis, enter. So 15529.62. Which one is better? 15529.62. Which one would you prefer? I know it's not a big deal, big difference, but every yes. So you will choose. You will say to the bank, don't compound my interest at 8.89 continuously. I prefer 12 times a year. Yes, monthly, correct. Monthly at 9%. So better. That's what I would write. Just better. Okay, very good. Next question.
I don't have a question for you.
Yes?
But I would like to go over half-life.
Yes. Very good. So let's find a problem at the end of chapter 4. Very good. Okay, chapter 4, and this is in 4.5. Let me see if I can find one here. Population, exponential growth. Okay. There is none at the end of chapter 4. Let me look at 4.5.
And we're not given that formula, are we?
It's the same with the minus in front. It will be given to you.
Okay.
So if you remember, we talked about it.
It's like AO.
Yeah, so it's PE to negative KT.
Okay.
So same formula as continuous compounding.
Okay.
And the same
But if
formula.
it's half-life, you divide by 2, right?
Yes. So I'll find the problem in just 1 second.
It's like 30.
Yes, I'm looking at 530 and I see, yes, problem 30. Let's take a look at problem 30. Very good pick. Of the problem, not of number 30. So the half-life of aspirin in your bloodstream is 12 hours. Okay. How long will it take the aspirin to decay to 70% of the original dosage? How long it takes to get 70% of the original? So let's write the exponential decay model, not with P because, so it's A of T equals A0 e to negative KT. They used K or R. In calculus is R, in others is KT, whatever.
What
So
does the K stand for?
the growth rate or the decay rate in this case. So let's say KT. It doesn't matter. It's just a letter, exactly. Okay, so I know that the half-life is 12 hours. So if I start with the original, then that side would be how much in 12 hours? 50%, correct? If I start with A0, in 12 hours, A of 12 would be half of A0, correct? Is that correct? Is that clear what I'm saying?
Yeah, 'cause the
So
half-life's
T,
12,
so
times-
yes, so T equals 12 hours means A of 12 will be the original divided by 2. This is what the half-life is telling us. So in 12 hours, whatever I start with, A of 12 will become half. Is that understood? So then, can anyone dictate the equation that I should work with? Exactly this. I would like you to say this, but tell me how to write it. The left-hand side is A0 over 2. No. Yes, but I don't want to use a name. I want to use the expression. Correct. Yes, A of 12, which is A0 over 2. And the right-hand side is?
A0.
Very good.
P
Yes.
minus, negative KT.
How much is T?
12.
Yes. So that's the trick. Remember when we say A of 12, we say when T is 12, A is A0 over 2. That's the point. 12, comma, A0 over 2. So when the Y value is A0 over 2, the X value is 12. This will help us determine what? The only variable here. Exactly. Y. And you can see what about A0? Not a problem. I divide both sides by it. So the original amount doesn't matter. Whatever the original amount is, it will be half in 12 hours. So then 0.5 equals e to negative 12k. What do I do now? Because 0.5 and e can never be presented with the same base.
Natural log.
Correct. My only chance. Natural log, natural log. Natural log 0.5 equals negative 12k. What is he saying? What are you saying?
It's a different version, right?
So then k equals natural log 0.5 divided by negative 12. So I grab my calculator and I put natural log 0.5 and I divide by, in parentheses, negative 12. So I got, don't forget, use 4 decimal digits for the decay rate or the growth rate, 0.0578. So then the model is A of t equals A0 e to negative 0.0578 t. And now I can answer the question. But what is the question? How long it takes for the original amount to decay to, let me read again because let me make sure it says 2. Yes, it says 2. For the aspirin to decay to 70% of the original dosage. So I take an aspirin right now. Let's say it's noon. At midnight, if I took 100 milligrams, I still have in the bloodstream how much? 50. I take now 100 milligrams. Let's say it's noon. At midnight, I still have in my bloodstream 50 of those 100, according to the model. But I want to know how long it takes till that 100% or 100 milligrams decay to 70 milligrams. Not all the way to 50. So, what?
Would you make A of 70?
Yes, 0.7 of A, yes. So now the amount is 0.7 A0 equals A0 e to negative 0.0578 t. Now, will we get the answer t less than 12 hours or more than 12 hours?
Less than.
Of course, because it decays to 50% in 12. To decay to 70%, it will need less than 12 hours. Agreed? Perfect. Okay, the same procedure. It doesn't matter how much I took. Natural log of 0.7 equals negative 0.0578 t, and I get t. Natural log 0.7. It's nice when I say 0.7 and write 0.5. Negative 0.0578. So I divide natural log 7 by the previous answer, the whole answer. And I got
Oh, so in order to do like half life, you have to find K first, and then you have to do T.
yes, because I even if I put in there 0.7 A0 and I simplify A0, then I have T and K unknown, and I can't solve.
Okay.
So first I have to find K. So natural log 7 divided by negative 0.0578. Okay, I got 6.2 hours approximately. Does it make sense? 6.2 hours. Good. Anything else? Anything else you would like to go back to review? Anything else that you can think of?
And exponential growth is the same. It's just not negative.
Exactly. The formula does not have a negative in front of K. Exactly. Everything else is the same. What else would you like to? I'd be more than happy to start reviewing for the final. Because if you want. Yes.
I have one more
Yes.
estimation.
Yes.
So they want you to find the sum of the summation. And they give you the lower limit, or the index, I'm sorry, is A equals 0. They give you the upper one is 4, and the equation they give you is
The expression, the general term, correct.
in parentheses, negative 1 raised to the k plus 1 over k factorial.
Very good. Awesome. Okay. So we're given a general term, which is negative 1 raised to k plus 1 over k factorial. And we're given k that goes from 0, 1, 2, 3, 4. How many terms do I have to write? Let's write those 5 terms first. When k is 0, how much is 0 plus 1? How much is negative 1 to 1? Over 0 factorial. And remember, 0 factorial, I know you're going to say why, How is it possible? We've never seen this before. 0 factorial and 1 factorial mean the same thing. That's the convention. 0 factorial and 1 factorial are both 1.
So that's independent one.
I'm sorry?
So that basically.
Yes, yes. I just wanted to write it for everyone to see. Yes. Plus, now when k is 1, 1 plus 1, negative 1 to the second power, 1 over 1 factorial plus. When k is 2, 2 plus 1, negative 1 to the third, over 2 factorial, plus. When k is 3, 3 plus 1, so 4, 1 to the fourth, over 3 factorial, and the last one plus negative 1 over 4 factorial. Very good. And now we're trying to simplify as much as possible and see how, so correct, negative 1, obviously plus 1, minus 2 factorial is 2 times 1, plus 3 factorial is 6. Very good. And 4 factorial is 24. Of course, the LCD is, this needs a, very good, this needs a
I'm sorry, 4.
4, and this one I shouldn't even bother with. So this is negative 12 plus 4 minus 1. So 4 minus 1 is 3. Negative 12 plus 3 is negative 9 over 24, or negative 3 over 8. Simplified by 3.
So for these ones,
Is this okay,
yeah. Oh, sorry.
William?
Yeah, no, I see where I made my mistake.
Okay.
You have to add an extra one, like because the other limit's 4, but we had to do 5.
Because k is 0.
So if k was 1, we'd have to.
We would only have, that's why I asked from the very beginning, let's see how many terms we have. When k is 0, 1 term. When k is 1, second term. When k is 2, when k is 3, when k is 4.
Okay. So if k was 1, we'd only have 4 terms. Okay. But because it was 0, we have 5. Okay. Can you move that?
Next question. And also, the other thing that I would like you to discuss, how you feel about this class being over 13 weeks instead of 15. If that helped you, if that didn't help you, if you, whatever.
Oh, yeah. That is 6 right now.
Because I think we're trying to have this class in 8 weeks.
Are you kidding?
What?
My friend's taking this class over the winter.
In 4 weeks, right?
Yeah.
What? Or 5.
Yeah, it's like 4 or 5. I think
It's like 2.
I mean, if you're taking
It's gonna
nothing
feel like
else but this class.
You don't
maybe-
breathe. You don't sleep.
No, I'm not doing that now.
You go to the bathroom every other day.
Good. Next question, please. Next question. So this is the last day of those 6 minutes. So yes, next week we do not have to extend, but of course you will have extra time for the test. But we made up over the last 2 months. We made up the extra time, the time that we missed.
I don't mind the extra time.
So next question, please. What else would you like to go back to?
Oh, could you do number? No, I think we did that one.
Can we graph log x minus 6?
Good. What do I have to write to find the domain?
X minus 6 greater than.
I tortured her enough now. She's never going to forget this. Doesn't remember anything. She's going to call me at 3 o'clock in about 5 years, 3 a.m., and she's going to say, I do remember. So yes, the domain is 6 to infinity. So you understand the domain is extremely important for so many, many reasons, but especially where the function is shifted, if you want. If you forget where to shift it, once you find the domain, you know exactly where it's shifting. Where is it shifting?
To the left. No, to the right, six.
So where will the vertical asymptote move then? Yeah. So the pure log function, because it's base greater than 1, it will cross at 1. So this is log x. But once you move it to the right, then you have to shift the vertical asymptote 6 units. So this is 1, 2, 3, 4, 5, and 6. So this is your vertical asymptote. And now, so my indicator moves where? Yes, at 7 indeed. Because it's 1, 2, 3, 4, 5, 6. So this is log x minus, I wanted to write 6.
And the range would be 6.
The range of the log is always all real numbers.
Oh, okay.
Because it's
So
the inverse of the
domain would be
exponential.
6
Yes,
to
the
infinity.
domain is 6 to infinity. Remember, the exponential is defined everywhere and has range 0 to infinity. The log has domain 0 to infinity and range all real numbers. They are reversed, right? Because they are inverses of each other. Okay. Next question. Anyone knows what happened to Stephen?
I have no idea.
I hope he's okay. Next question.
He was smart.
I don't know what happened.
Maybe just watching.
Yeah, maybe he's just watching the lectures and he'll show up on the final.
I
You
hope
can't
he's,
tell us his
I hope
grade,
he's
but he's doing well in class.
very well.
He's got a
Yeah.
lot, like, a
Maybe
lot of
he's
his
still
homework's done.
Yeah, he worked very hard.
I don't know what cameras are.
So, any questions? So our test is Tuesday. Okay, good. So can you please finish the homework, my math lab homework, please?
I'm so close, like I just love seeing like the entire math labs like almost completed. Cause like in the beginning of the semester, like was really overwhelming now with the stuff.
Me too.
Yeah, like, the thing that I'm saying about
Yes?
it, it's not, it doesn't cause a problem mathematically.
Yes?
Like, it doesn't cause a problem for the